Kwakhona ndiyanamkela ku-YouTube wam. Cela si-enjoyeni this question together. Upper we are exposed to a number of sigma notation formula questions where we need to unpack these different types of series, which is this one, I believe it's a linear, and this one is a geometric, because we can see that we have AR, then n minus 1 there. Then this one is sum to infinity. Of course, sum to infinity only found on geometric series, where R is between -1 and what? And 1, but R can never be equal to 1. So this is just what we have for now. And we are having this portion, and we said this one is a linear pattern and this one is a geometric pattern. Then now what do we need to find? We are looking for the value of y, this value of y, if this everything else is given this way. But what we need to be mindful of, first of all, we need to know how many number of terms that are in the particular sigma. Now what are we having here? We have a p starting from 1, then therefore the last term is 5, right? Yes. So we just need to remember that this 5 is not necessarily the number of terms, and yeah, this is the last term, and from the terms that are being added, that this is the last term. It is term number 5, but it depends with you, when did you start adding these patterns, because you can start from a pattern number 3 up to pattern number 5. It doesn't mean that you have 5 terms to that are added together. It's just that the last term is T5 from a certain pattern. So this is what we usually get confused on. A typical example, let's say we have 1, 2, 3, 4, 5. So if you are interested in adding these ones, yes, this is the complete pattern where you have T1, this is T2, this is T3, this is T4, this is T5. So now if you are interested in adding this the fourth and fifth term, which is like those ones, then therefore these other terms will be omitted from sigma or from the sum, because now you are not adding these ones, you are adding from T4 to T5, and you're not going to say this is T1, because now you are adding the first and the second one. It's not the first anyway. This is the fourth term from the complete sequence or series that was given. So that is why now we're gonna say, if you are having this kind of situation, then you can have your sigma having starting from the, let's say you can just say n starting from 1, 2, 3, 4. So you can say starting from 4, then therefore to the last one is just what? Is just 5. Not necessarily 5, but yes, of course, the 5 is the term and also the position is 5. So it's a coincidence, by the way. Now, on that note, you can see that you are having starting from 4 to 5. So how many terms do you have? You just have 2. But how do you then calculate the number of terms when you are given the series in sigma notation format? Now, you just say, okay, in this case, you are having the number on top, which is, you can say the number on top. Then this one is the number that is found on the bottom side. So this is top, this is bottom. So to find the number of terms here, and of course we know that there are 2 here, but how do you get this 2? So the number of terms is equal to the top number minus a bottom number, then plus 1. So it's always the case that it's a top minus this one, then plus 1. So you will always get the number of terms that are in that particular pattern, because this 5 is not necessarily the number of terms. So this is where most people used to make mistake. They usually consider this 7 as the number of terms, which is not. It depends on what is the starting value, what is the starting position. Is it 1? So otherwise, if it's 1, then therefore 7 is going to be the number of terms. But if it starts with another value, then you have to consider something out. So that's the situation. So let's move to the actual answering of this question, what it has and what it's have for us. We are having this linear. We said this one is the linear pattern, and linear pattern, we need to remember what is the formula for a sum of a linear pattern, and it's gonna be n over 2 then a plus l. So I like this one, especially when you can find the first and the last term, and also the number of terms are also there, so you don't necessarily need to find the common difference and stuff like that, and use that long formula. But this one is so sophisticated. Now let's come to the second one, and the second one is a geometric series. Geometric series, it's having a common ratio, of course. Then on this note, we need to remember the sum of geometric. It's what? It's a into, then you r, then to the power of n, then minus 1, then all divided by r minus 1. So this is what we are going to use as. Then on the other side, we can see that this is sum to infinity, which is a convergence series, of course. That its formula is sum to infinity, which is equal to then a over 1 minus r, where r is between 1 and negative 1, because it has to be a convergence series. If it doesn't, then you can't find the sum to infinity. Now let's go practical and solve this solution. And otherwise, I just needed to first break down some of the information, so that when we go along with this question, we don't leave each other behind. Now what are we having? Let's first just find the first term. Finding the first term is to substitute by that first position, which is p is equal to 1. So when you substitute by 1 in the place of p, you will actually get the first term, which is a in this linear series. Now, which means a is equal to, we have 4, then we're gonna have 4y, then the 4 plus 3 times 1, which is just going to be that. So this is our a. Then we can also find our last term, which is going to be 4. After having 4, we have 4, then y, then plus, and then we have 3 times 5. We're gonna put 5 here, because we are going to put the last position anyway. So the last position is position 5, ne? So on that note, we have 15, because 3 times 5 is of course 15. And we also know that for this pattern, the number of terms is what? You can just write it here. The number of terms is just 5, which is the top number. Then this one is the bottom number. So it's 5, which is 5 minus 1, then plus 1. Because we said the top number minus the bottom number, then plus 1. So this is just what we have. So which means now the number of terms is just still 5. No story. Now coming to this one, we just need to find the first value, which is the first term there. We really need to find the first term. So finding the first term is to substitute by this starting amount, or this starting value, sorry. Now what are we having? We have 3 times 2 to the power of, in the place of k we put 4, then of course we subtract 1. So what are we having? We have 3 times 2 to the power of 3 is 8. So it's 3 times 8, which is just what? Which is just 24. So our a geometric series is a is equal to 24. Wow. And our r, you can see that our r is just that 2 over there. And it's not always the case that our r is found there. You just need to find the first 3 terms, then therefore you divide the second term by the first term to get the ratio. But for this one, it is easily seen that r is equal to 2. So when you have r and a, yeah, you are almost done with that one because you just need substitution. So let's come to the right hand side. The right hand side is sum to infinity. So sum to infinity, we know that we need a. Then our a, how do we get a? It's to substitute by this starting point. Then therefore we have 1 over 3. Then in the place of j we put 1, then 1 minus 1. Then we know that this thing is powered by 0. Then therefore your a becomes just 1. No story. Now, and also your r is of course going to be equal to just 1 over 3. Just 1 over 3. And of course you can see that your r has to be between -1 and 1 because the infinite series has to be convergent. Now let's come to the application or the substitution to the formulas so that we get the value of y there. Now, what are we going to say? We are having this formula which says n over 2, which is now in the place of n here. In the place of n, we have 5. So we put 5 here, then open brackets. Then therefore we have a plus l. Then our a is 4. Then our is 4y. Then plus 3. Then we also have plus our l is this one, so we also have 4y plus 15. Then therefore and 4y plus 15, so we have y here. Good. Now this is a linear pattern. Then therefore remember that there is a plus sign here. That plus, when you say plus here, we are going to add the sum of this geometric pattern over there, which is now we know the formula is a is a and our a is 24, then a in brackets, then our r is 2, remember. Then to the power of n, our n is equal to, remember, the n value there is the number of terms. So the number of terms is to use n is equal to, the top number is 7, then top number minus the bottom number, then plus 1. So it's always that like that. So the answer is just gonna be 7 minus 4 is 3. 3 plus 1 is 4. So we raise it by 4, then the 4 minus 1, all divided by 2 minus 1. So I hope you still remember these formulas because now we just apply them without referring to anything. Then this is equal to the sum to infinity, because this is equal to sum to infinity. Sum to infinity, it just needs a, and a is found to be just 1 over, then r 1, it's 1 minus r, then r is 1 over 3. So we can now continue solving the rest. Now what are we having? We have 5 over 2. Then we have 4 plus 4, which is 4 plus 4, which is going to be 8y. Then therefore plus 18, because 3 plus 15 is just 18. Then let's just have 8y here. Then therefore this is what we have. Then plus this plus sign, that plus sign. Then plus this one is gonna be what we are trying to simplify as far as we can. Then this 2 minus 1 is just gonna be 1. Then this one is just gonna be 16 minus 1 is 15. So then 24 times 15, then 24 times 15, then we have 0 here. Then we have 10, then we have 0 here, then we have 10, we have 12. Yes, then therefore we have 0, we have 4 here, then we have 2. Yes, then therefore the answer is just gonna be 63. So upper we are having 360. Then therefore this must be equal to sorry for this one. This must be equal to the other side. We are having 1 over then this is 3 minus 2 minus 1, which is 2 over 3. So this is just 2 over 3, which is gonna give us just 3 over 2 on the other side. Then let's simplify. Then this 2 is going to cancel this one, check 4 upper, and also cancel this one, check 9 upper. Then 5 times 4, which is gonna be just 20y, then plus 5 times 9, which is just 45, then plus 360, which is equal to 3 over 2. So we can just take everything else to the right hand side just to for ixesha. Then we have 3 over 2, then minus 360, then minus 45, then this is what we have, then divided by 20, and this is just what we have. The answer is just 20, is just y is equal to negative 20 comma 18. So the y value is negative 20 comma 18. So I believe we got it all, and otherwise it was not the easy thing, but you just need to break down what you have studied and combine it together to form this giant thing. Otherwise there's nothing that was difficult here. You just have to play with numbers and get what is required. See you when you see me.